Hey class, this is the second video for the momentum series, and this one's on conservation of momentum. Just like mass, just like energy, momentum is always conserved. It's always constant. So the initial momentum has to equal the final momentum, the total that is. So look at these two examples. First one, we have cart A weighing in at 12 kilograms, moving at 22 meters per second. Cart B, weighing in at 8 kilograms, is moving towards cart A at 13 meters per second. Bam! They collide and both carts go in the opposite direction. The question says, what is B's velocity post-collision? So we're looking at cart B, and we're looking at its velocity after it collides with cart A. So first thing we're going to do, what are we looking for? So question mark, velocity, and I'm going to specify final B. So the velocity final for cart B. Now, what is our formula? Well, it looks like this. That's supposed to be sigma. It's a hard symbol to draw. The total momentum initially has to equal the total momentum at the end. So we simply add up our momentums. They have to be the same before and after a collision. So first things first, we got to get the pre-collision momentum. So for cart A, we've got 12 kilograms. And again, our formula for momentum is P equals mv. So for cart A, we've got P equals its mass, which is 12, times its velocity, which is 22. And then for cart B, we have its mass, which is 8, multiplied by its speed, which is 13. All right, do a little mathematics here. 12 times 22 is 264. And 8 times 13 is 104. Now we're not worried about units at this point because we know we're talking about momentum. Now we're going to add these up. Plus gives us a total momentum before of 368 kilograms per meters per second. That's before. Now we want to find out the after momentum. Okay, well, let me make some room over here. Now, we know cart A's velocity after the impact. We don't know cart B's. So what we can set this up as A, B, cart A, still 12 kilograms. Whoops, forgot the P. And it tells us it's moving at 9 meters per second. Cart B, still 8 kilograms, but we don't know the velocity, so that's going to be our unknown. We do know the initial initial momentum total was 368. So this has to equal that. So we're going to say 368 equals the final momentum of A. So we're going to say 12 times 9 gives us what? I should know that. Is it 108? It is 108. 108. So 368 equals 108 plus 8 multiplied by our velocity. Okay, so now we got to do some simplifying. Subtract 108 from both sides. That gives us what? 260. So 260 equals 8 times V is simply 8V. And then we're going to divide both sides by 8. So our VBF is going to be 260 divided by 8, 32.5 meters per second. Okay, it may seem like a lot of work, but once you get the hang of it, it's easy to set up. Let's look at the second example, and let me draw a line so we don't get confused. The second example, we have cart A weighing in at 21 kilograms, moving to the right at 18 meters per second. Cart B weighing in at 11 kilograms, moving to the right as well at 7 meters per second. Now, cart A is moving a lot faster than B, so cart A is going to catch cart B eventually. And what happens is they stick together and they keep moving to the right. So the question says, what is the final velocity for the carts? Now again, our total momentum, I'll write that one more time. Total momentum before has to equal, that's horrible. Hey, at least I can admit when my drawing or my writing is bad. Total momentum before has to equal total momentum after. So let's find out what the total momentum before is. So first off, we're going to find A and B. So A, we know P equals mv, mass of 21, speed or velocity of 18. Now what about B? B is a mass of 11 and a velocity of 7. Multiply both of these out. 21 times 18 is 378. And 11 times 7 is 77. Then you're going to add them together, and you get 455 kilograms times meters per second. That's your total momentum before the collision happens. Now, that has to equal the total momentum of this after collision. If we want to find out the velocity, we know that carts A and B are now stuck together. That's a perfectly inelastic collision. So 455 has to equal carts A and B mass and velocity. But today, in this situation, they're connected, so we're going to add their mass together. So we're going to say AB mass times its velocity. So in this case, the mass, 21 plus 11, is 32 kilograms times its velocity, which is what we don't know. So 455 equals 32 times V, which is just 32V. To solve this, all we have to do is divide both sides by 32, and we get V for AB final is 14.2. We're going to round that to one spot. meters per second. So V for A and B, because they're connected, final is 14.2 meters per second. Which, when you look at our speeds, makes sense. One was going 7, one was going 18. The faster one is going to slow down, the slower one is going to speed up, and we've got a number in between those two velocities. If you have any questions on this, please let me know via email or remind, because I want to make sure you succeed during this momentum chapter.